Good morning, geometry students, and welcome to Monday. This is the third week of our digital school. We are getting ready for a test, so continue to kind of think about that as we move forward. But let's go ahead and start in prayer. Heavenly Father, we thank you so much for this day. We thank you for this opportunity to learn, and we ask that you be with us throughout our week here working on our grades for geometry class, but all our other classes as well. Help us to do well and perform well on whatever our test covers, and let us show that we've learned stuff these last few weeks, and help us to have a good day today. It's in your name we pray. Amen. All right, so as I've been going through this, I should have said this the other day, I kind of covered things a little bit out of order because I wanted to make sure to cover that right triangle where that line through the middle was given. So I covered things a little bit out of order from what I probably normally should have. But the other day I reviewed section 7.4 and 7.1. Like if you look those two up, if you look up the old lectures as well, those would help you out. So today I'm going to review 7.2 and 7.3. I actually think I'm going to kind of cover them in a reverse order because 7.2 is sort of like what we did a little bit yesterday, reviewing 7.1, or for your homework that's due. So if you remember from long time ago, we had congruent triangles, and we had 4 ways that triangles could be proved congruent. I don't want to mention those today because those are congruent, not similar. We have 3 ways that if 2 triangles are figured out to be these ratios or whatever, that they are considered to be similar. So please remember 2 things. Number 1, in order for 2 triangles, or any shapes actually, to be similar, corresponding angles must be congruent. So if you're given anything with angles, they have to be congruent. And corresponding sides have to be proportional. So if you set up proportions, every single proportion around the triangle or around the rectangle or quadrilateral, if it's a random shape, has to be the same. So if we set up the ratios, it can. Well, that would be a lot to set up if we had to do it every single time. So for triangles, we realize there's 3 shortcuts we can use. If there's 2 angles that are the same, the third one has to match and will automatically make the 2 triangles similar. So one of our ways to do a shortcut for similarity is angle-angle similarity. A second way, and the third way, excuse me, both the second and the third way are ways like when we did congruence, but there's not 2 A's in the word. So SSS did not have a single A even. So all 3 sides, remember then, all 3 sides, the ratios must be the same. And SAS, so an angle in between 2 sides, but when we divide out those 2 sides, they must be the same, okay? The decimal must be the same, or whatever you're using, however you're working with that. So the first thing I'm going to review, we're just going to look through one. I do have, like I said, this is lecture 7.3. If you want to get more examples, you can go back in my videos and look at section 7.3. But as a reminder, this is what we're looking at, okay? So you can go ahead and pause the video once I get the paper up there. And I know it's kind of hiding, and originally I wrote it in pen. It wasn't showing up the greatest, so I can read that to you. It says triangle NML is similar, and then there's a blank there. Please remember, we have to decide if we can fill in the blank, and then if we can fill in the blank, we need to just say what way. It's either SSS, SAS, or AA. Real quick, because a lot of you did this, and I wrote this on your worksheet, whether it was in email or over Google Classroom. If you decide that the 2 triangles are not similar, there is a chance that these 2 triangles are not similar. Do not fill in like triangle NML is similar to triangle. That's telling me that you think there are 2 triangles that are similar, but then underneath that you say not similar. If you decide the 2 are not similar, all you do, if this is problem, this says number 1, so I remember my examples. All you have to do is number 1, write not similar, and go on. Do not fill in a second triangle. You only fill in the second triangle if you have decided that the 2 triangles are similar. So let's look here. Triangle NML. Okay, NML. So if I look at that one, sorry, my pen's not quite working this morning. If I look at NML, that's the way I would swoop around there on that side. And again, it looks like 49 is shorter than 84, right? So that's just something important to kind of think in our mind. Anytime I see a bow tie, even if this bow tie is kind of twisted on its side or different things like that, even though it was not marked, I know I have vertical angles. So I know this has an A in it, but because these lines are not parallel, I cannot get AA. I only have a single A, so that means it looks like I might be aiming for SAS. Now, if I'm going to have SAS, I'm going to need to make a ratio of my other two sides. And it would really only make sense here if I would make a ratio of my small sides and my large sides. So if we look through this triangle right here that I already did the swoop through, 49 is small, 84 is large. Now that does not mean that that is necessarily the smallest and the largest side. Okay? Yeah, this side right here is unknown. It could be more than 84. It could be less than 84. We really don't know. But the two sides that I have, one has to be small, one has to be large. So I made a ratio. I haven't made a ratio yet. I listed my small. I listed my large. So now let's look at this other triangle. And I'm not even going to worry yet about what order it's going to go in because these might not be similar. Which one of these numbers is smaller? All right, so I'm going to write that on my small list. And then 48, that would automatically make 48 my larger of the two numbers. So I made a list here. Here's triangle 1, here's triangle 2, my small side, my long side, my small side, my long side. What I actually want to do is make those ratios. That means I'm going to divide them. Now, I could have done the triangles the other way. It's not a big deal, just as a reminder. If you're like, how come you set them up that way? Why didn't you write these numbers first? Okay, it's just the way I listed it this time. So then you'll take out your calculator. And right now, since I have 49 divided by 28, I'm going to do 49 divided by 28, and my calculator is telling me kind of a nice number, 1.75. Okay, 1.75. It is a decimal, but it's pretty easy to remember that for just a second. 49 divided by 28, your calculator told you was 1.75. Let's move to the other one, 84 divided by 48. If we do not get 1.75, which we did, I got 1.75. If those two would not be exactly the same, we would have to say these two are not similar. Okay, and that's why I didn't fill anything in yet. Now, since it is 1.75 and both of them were this 1.75, they must be the same. They were. If these two ratios down here are not the same, that means that our triangles would not be similar. But we got them the same. That means they're similar. Now we have to worry about our order. So notice I started at the vertical angle, went over the short side, and then the unmarked side. So start at the vertical angle, short side, unmarked side. So if I start at the vertical angle, that would be N. The short side would be going up across the 28. And then my unmarked side. Guys, I think I am going to get an answer of triangle NDC. Okay, so I could fill in this blank on this one. And why did we determine? Yep, we used side, angle, side. Remember that vertical angle came in between. And just because we need to make sure that we're knowing we're doing side, angle, side similarity, and we got those proportions the same, you have to write that. All right, so as a reminder, there's actually 3 ways you could list right there. You could have side, angle, side, which is the one we just got. You could have side, 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 or you could have angle, angle. So these are the 3 for when you're doing this part of the homework. Those are the 3 that would be okay to use. Side, angle, side similarity, side, side, side similarity, or angle, angle similarity. All right, guys, so when we have 2 separate triangles, it's usually pretty easy for us to figure out and see how to get the 2 separate triangles and figure out like what X is or what question mark is or whatever. But sometimes when we have overlapped triangles, it's kind of tricky. So if you would please work on copying this down. We're going to work on this one. Now, once again, a few other times I've used some of these papers to help me out. And so I'm going to use a couple of these Post-its right now. How many of you see this little triangle right here, and I know with the light and stuff like that, and you have a 7 right here, an X right here, and a 10. Actually, guys, sometimes, a lot of times when the computer gives us one like this, they give us more information than necessarily we need, but that works well. We can use whatever one we want. So I have my 7, my X, and my 10, right? So I have that triangle right there. This is going to be the one that's a little bit tricky using these Post-it notes because of how it is, okay? It's going to cover up a little bit too much information, but it's going to be really close and help me out. How many of you see that bigger triangle now? And since I see that bigger triangle, I don't want to use this 7 and the X. I need to use 117 and 63. All right? And so those are the 2 triangles I have. So quite honestly, I'm going to write down 3 ratios this time. Would you look, and you can either do what you already see right here, 17 over X. Just think about this, 117 over X. And you can see that 117 is the full length, so you would know 1/17 is the longer of the 2. So we could write 117 over X. Actually, we definitely need to write that one because it has the X in it. Since I listed the 117 first, I'm going to always need to list my big numbers first. So I would do 90 over 10. And guys, since I have 2 ratios that I know are in similar triangles, because when they overlap like this, they have to be similar. When I have 2 ratios already, I can just stop and be done. If I really would have wanted to, I could have gone on to the third side and said 63 over 7. But the thing is, I don't need all 3 of those. I really only need 2 of those. So if you were already doing this on your own and you had 63 over 7, don't think you are wrong. Whenever we're trying to solve a ratio, we write an equal sign in the middle. We're going to cross multiply. But remember, hopefully you learn this. When you multiply by 10, it actually makes it really easy. You just add a 0 to the end of your problem. So 117 times 10 gives me 1170 equals, and then cross the other way, 90 times x is 90x. Those 2 are equal to each other. So the one last thing we have to do on our calculator is 1,170 divided by 90. And so x would equal 13. Okay, and you would obviously get that same answer if you use that 63 over 7. You also would get the same thing if you would have had the ratios flipped upside down. Okay, not a big deal in having the ratios flipped. So number 3. And example number 3 is going to be, sorry, my coffee tastes really good this morning. Example number 3 is going to be my last example for today. Oh, one more time, guys, because it's going to be the question at the end of the day. What type of mug is Miss Jabs using today? An Eeyore from like Winnie the Pooh. I really liked Winnie the Pooh when I was like a long time ago. It's not so much around anymore, but random fact about Miss Jabs. She liked Winnie the Pooh and she really kind of liked Eeyore. So anyway, this next one that we have is a little bit trickier because did you notice what was true about this bottom side right down here? You had x in a binomial. Remember, anytime it's in a binomial, we want to give it that possession of staying together with the parentheses. That also means anytime you see a binomial, you are going to have to distribute to answer your question. And so let's see here. There's a bunch of ratios I just said we could set up. I could either do 121 over 66. I also could flip that and do 66 over 121. Looks like down here at the bottom, I'm going to have to do 8x plus 6 over 143. That is going to have to be one of them that I use. And then I could use this 72 over 132. 132, okay? So guys, the way this drawing is, it already sort of shows me a very nice ratio right here. So I'm just going to rewrite that ratio. I'm going to rewrite 8x plus 6 over 143. But please realize when I write that, 8x plus 6 comes from the small triangle and 143 comes from the big. So I have to now list small to big. So if I was going to use this one, it would have to be 72 over 132. If I was going to use this one, it would be 66 over 121. It really doesn't matter. Tamia, which one would you like to use? All right. I don't know if that's what she really said, but I like pretending to call on people because I miss seeing you. I hope you guys realize how much I miss seeing you guys every day and greeting you in the morning. So let's use 72 over 132. That's what it sounded like she said. Even if she didn't, it's okay. Just make sure that both of these now have small over big. Please also remember, we want to remember that this has to go together, so we have to keep it in parentheses. Let's do the other way first, guys. These are going to be big numbers. It doesn't matter. It should always work out to be a nice answer. I got 143 times 72 is kind of a big number. 10296. 10296. Okay, if I cross the other way, don't forget this is a binomial right here. So I am going to put this one in parentheses at first. And so I get 132 times the binomial of 8x plus 6. So I'm going to have to distribute. Once again, I'll use my calculator to help out. 132 times 8 is 1056, 1056. And 132 times 6 is, that typed in wrong, 132 times 6 is 792. All right. So I'm just going to check those numbers one more time because I don't want to be going on here. The other day, apparently, I said something wrong. That was obviously just a error on my part, and I apologize. So it looks like we have 10,296 equals 1,056 x plus 792. So doing a little bit of just regular algebra, subtract 792 from both sides. So 10,296 minus 792 equals 9,504. And that is equal to our 1,056x. And so if I divide that by 1,056 to get rid of that and cross that out, it did come out to be a nice even answer of x equals 9. Hey guys, when I set these up, I make sure that the computer gives us nice whole numbers. So I'm about to hold this up because this is the last example I have for the video. Okay, so please just send me an email and say, hey, Miss Jabs, we're getting ready. Like, you don't have to say it this way specifically, but we're getting ready for a test. How are you feeling as we did the review homework the other day, as I reviewed these few things today? How are you feeling towards a test? Are you feeling pretty good towards this first test? A couple more days of review. Guys, it's not going to be tomorrow. We're still not sure on Wednesday. I'm kind of thinking Thursday would be a good day just to make sure that everybody tries to get it in. And just so you know, I probably would have it either post in the morning and have you try to get it into me, because that way I know I can be helping you. Like, I'm on Google Hangouts, and if you have questions, you can call me, okay? So I'm still trying to figure that out. So I haven't officially set a day, but a few things. Number one, what type of mug was I using before? Okay, I might take another sip real quick here, so that's an answer to you. Number one, this is in an email to me that says today's date, which is March 30th. What type of mug am I using today? Number two, if we were going to take a test, is there a certain time you usually work on homework? Like, if I gave like a morning session, like you had to take the test between like 9 and 11 a.m., would you be able to make it? Or would you like me to offer a second session and do a second session at like maybe like 2 to 4 p.m. or something like that, if I offered a couple different sessions? Okay. And then, so question number one, what type of mug was I using? Question number two, what time would you like the test to kind of appear and show up and have it to work on it? And question number three, as we're preparing and getting ready, am I feeling ready for the test? Do you think you feel ready for the test that we're about to have? So once again, here is the answer to that last problem. Zoomed in a little bit so you can see the work. And I hope you have a great day. I miss you guys. Bye.